Okay, guys, this is 3.1, second video, and I'm going to continue trying to graph these. So I have f of x equals x squared minus 6x plus 7, okay? Now notice this isn't in that nice form, that form we like, f of x equals a times x minus h squared plus k. But we can definitely get it in that form, okay? So what we're going to do is we're going to use our handy dandy friend of completing the square, okay? Now it's a little strange because now we just have f of x equals, but it still works in the same way. So I'll take x squared minus 6x plus blank, okay? Now instead of moving 7 over to some other side of an equation, I'm not really doing that in this case, I'm going to just go ahead and I'm going to subtract off the blank. And the reason I'm doing that is because whatever I add here, I have to subtract here because this is all happening on one side, right? So I have to keep the function the same value. And I'm going to go through and I'm going to do this the same way. I'm going to divide this by 2, and I'm going to square it. And it'll go here. And if I put a 9 here, I have to put a 9 here. Now, if you remember the trick to this, the way this is going to factor as a perfect square is just going to be x minus 3 quantity squared. Then I have plus 7 minus 9, that's minus 2. And lo and behold, I have this in that nice form, that a times x minus h squared plus k. So what did this tell me? Well, it tells me a few things. It tells me that I have a vertex at 3, negative 2, right? Because that's my h and my k, okay? I know I have an axis of symmetry at x equal to 3, just the value of my h, okay? I know that this thing opens up since a is equal to 1, so it's positive. So now I can draw this thing quite easily there. So 3, negative 2 is right here, okay? So 3, negative 2. And I know this thing is going to open upwards like this. And here's my axis of symmetry. So this is the line x equal to 3. So we have our graph here. Now, I would encourage you to think about how you might find the x and the y-intercepts here. Remember what happens at x-intercepts? That's when the function value is equal to 0. And when we cross here, that's when x is equal to 0. So you could easily find those, and you may have to in an applied problem, hint, hint. Now, the last thing I want to do is I want to talk about the domain and range of this thing. The domain here is negative infinity to infinity. We can see that from our graph, or we can even see that from our function. And our range is anything, we're looking at our y values from negative 2 up. So negative 2 to infinity. So I think those are important things to look at. You can see that it's decreasing from negative infinity to 3 and increasing from 3 to infinity. So let's take a look at C. C says f of x equals x squared minus 10x plus 21. So I'm going to do the same thing. F of x is equal to x squared minus 10x plus blank plus 21 minus blank. Notice the setup is the same way. I'm going to go ahead and complete the square. I'm going to get 25 here. If I put a 25 here, I have to put a 25 right here as well. Okay. So that's looking all right. So let's go through and see what we get. That means f of x is equal to x minus 5 squared minus 4. So just as before, I have a vertex now, and my vertex is 5, negative 4. I have my axis of symmetry, that's x equal to 5. And I also have that my parabola opens up because the a value once again is 1. So I'll put that in. 5, negative 4, and we're opening upwards with our axis of symmetry, x equal to 5. We can find the domain and range. We can find the intervals on which it's increasing and decreasing. I suppose I'll do the intervals this time. So when is this thing increasing? I can see that it's increasing from 5 to infinity. Now remember, we're talking the x values here. So from 5 on. And I can tell it's decreasing from negative infinity to 5. Okay, let's continue on. There's one other way of doing this. If you're not a huge fan of completing the square, you can also do it this way. And yeah, I guess that's a proper name for it. So if we look at this one, an alternative way to graph is f of x equals ax squared plus bx plus c is you could use this formula right here. Okay, so if I use that formula, now first of all, you need to have your function in this form. Okay, and then you can find your h and k like this. Okay, so first of all, if I look at this, a is that first value, so I do know it's going to open up since a is equal to 2. Now, if I want to find h, I know that's negative b over 2a. So this is an alternative way if you want to memorize the formula. Okay, so this is going to be negative b, so negative 4 over 2 times 2, right? That was my b value. 2 negatives make a positive, that's 4 over 4, which is 1. So I have my h value, and then my k, according to up here, is f of h. So it's f of 1. That's 2 times 1 squared minus 4 times 1 plus 5. That's going to be 2 minus 4 plus 5. I guess that's 7 minus 4. Looks like that's going to be 3. So now I also have hk is 1 comma 3. So 1, 3 right here. I know it's opening upwards. Looks like there's no x-intercepts. Okay. So I'm going to open up. And I know my axis of symmetry is the equation x equal to 1. Okay. Now, you could find the y-intercept. I wonder what would happen if you tried to find the x-intercepts, right? If you set the function equal to 0, I mean, you're not supposed to really get any real numbers on here. What would happen? I encourage you to try that, okay? You'll probably see you're going to get some imaginary stuff, so you might want to use a quadratic formula there. And that does it for the second video on 3.1.